This is Mike Farrar. I'm here at Preferred Pump in Tyler, Texas, and we're going to talk today about how we go about testing motors here at the branch. Different instruments we need. First is a go, no-go gauge to measure shaft height, to make sure that the motor shaft height is in spec with the manufacturer. Second thing is just a simple yardstick. What we're going to use this for is for measuring when we have a motor and pump combination, make sure that the two are in alignment. We have a torque wrench. The torque wrench is used to measure the force necessary to turn the shaft motor, again to make sure that we're within spec. We have two megometers here in front of us. They're also commonly called meggers. We have one digital display, we have one that's an analog display. Either one will work fine for the application. And lastly, we have a standard voltmeter, and we're going to use it for measuring winding resistance of the motor.
The first thing we want to do when we get a motor back in the branch is just an overall visual inspection. Is there a lot of dents and dings in the motor housing? Are the leads cut or spliced or mashed like we often see, which is indicative of rolling around in a truck? As you know, your sales guys throw them in the back of their trucks. The customers do the same. They roll around for a week or two and then finally make their way to the branch. When doing your inspection, it's important to reach up and grab the motor shaft and spin it, see if it spins freely or drags or has any problems. Sometimes they do get stuck. You may have to take a pair of channel locks or a tool and help it get started, and a lot of times they'll spin freely afterwards. If not, you know that the shaft is indeed locked. Another consideration to look at when determining motor failure or diagnosing motor failures is the go no-go shaft height gauge we discussed earlier. As you can see, when properly put on top of the motor, it should just be able to swing freely. If the thrust bearing is out on the motor, the shaft will have dropped. This also gives you problems with your pump end. The stack falls, starts grinding, motor short out. So it's all kind of a train of events that you have to look at. Some motor manufacturers do not allow this. You have to give them an actual measurement. You can get a scale to determine exactly what millimeters you're working at. Everything is measured from the base of the motor to the top of the motor shaft. Because this particular one does not have an extension, you just simply use your go no-go gauge to determine what it is as a straight edge. So you're at 38.36. This particular motor manufacturer, 38.2 I believe is millimeters is their spec, so there's nothing wrong with the thrust bearing. The shaft height is appropriate. As well as visually looking at the spline itself to see if there's any wear marks from sand. Oftentimes you'll see it caked in around the top of the motor, around the leads. You can see abrasion marks on the side of the motor. Sometimes you'll see the bottom of the motor swollen out from electrical surges. The motor itself is a blue or black color. Sometimes a strong enough electrical surge will create a hole in the side of the motor, which is pretty easy to see. A lot of times, depending on your area, the color of the motor can tell you a lot. Is it clean water? Is it very irony water? Iron accumulated on a motor helps create heat, or helps keep heat in, and can oftentimes lead to motor failure, premature motor failure. And you can see the iron that stains and is stuck to the side of your motor. This is a much smaller unit, 3/4 horsepower. It can be tested the same way the larger motors were tested. You still have your insulation test from ground to your different leads, though you only have two. You still have winding resistance parameters that you can test line to line. This particular unit that came in did not show to have any problems. We've already tested it. We did check to see if there was any problem with the alignment. Just a simple straight edge will take care of that. So everything is done the same way. You can continue to break this pump and motor apart to do shaft height test, etc., until you find the problem or find that there is no problem and can be returned to the customer. This particular one has a cracked discharge head, and as you can tell by the condition of the leads, had never been installed. The dealer found it before it became a problem. But all motors can be tested the same way, with the exception of the SQ pumps that are a little bit different in nature. It's simple test without a lot of electricity, a lot of power. You don't have to set them up in your test pit to see if they pump, if they work. In fact, insulation resistance should be checked before you ever try to run anything, because the electricity that's being shorted to ground can actually be conducted through the plumbing in your building, in your tank itself, and can be very, very dangerous. Here we have a Grumpus 5-4 single phase motor that we're going to do some simple non-power on insulation tests. The first thing you want to do is put something in between yourself and the motor that doesn't conduct electricity. We'll be putting 1,000 volts of DC power through this motor, trying to find the path to ground. Naturally, if your motor is shorted to ground and you were to do this test on a metal table, it would conduct electricity through the table as well. So consider the surface that you're doing your test on. Very important. Here we have a simple UEI. This is the digital version of a 1,000 volt megger. While megging a motor, essentially what you're doing is putting 1,000 volts of power, DC, through the lines of your motor, trying to find a shortage to ground. If you can equate it to pressure in a plumbing system, essentially you're trying to find a leak in the plumbing by putting 1,000 psi on the lines to find the leak. I wouldn't recommend using anything less than 1,000 volts of DC power for an application such as this. Pretty simple test. You want to hook your earth line up to your ground, and we'll test each one individually to determine if there is a path to ground. So here we see a value of 10 or 11. Again, a value of about 18. And a value of 12. Be certain to turn the power off in between testing each one of the leads, as it will conduct 1,000 volts electricity through this, through the individual conductors or your fingers, whichever one comes first. We can see through the values that we're taking that this motor has a significant amount of shortage to ground, with the acceptable parameters being 20 or above, megohms that is, to be reinstalled. This one clearly falls below acceptable values. Let's move on to our line-to-line resistance. This is done with just a simple voltmeter. Black to yellow. And we know the acceptable parameters for this is 0.67 to 0.83.
1.8.
And we are at 1.8. We know because we've already zeroed our meter that it is 0.2 ohms off. So we know that's 1.6, which falls well outside of the parameters that we have by Grundfos of 0.67 to 0.83. Next, we'll test our yellow to red or our windings.
.9.
Which falls within acceptable parameters once you subtract the 0.2, which are 2.21 to 2.71. So we know that the insulation resistance on this motor is poor, and the winding resistance is not within manufacturer specs. Helps you determine if this motor has a problem, what the problem could be. One thing to consider when you're testing insulation of a motor is that once the degradation of the insulation has started, it will continue. It will not stop. To install or reinstall a grounded motor can be dangerous and cause your dealer to have to reinstall a new one in the near future. Do these tests before you ever put one in your test kit. It can electrify the plumbing systems, your test tank, and be dangerous for anybody else.
Once you've tested the visual observations, the electrical testing, you found that everything is within spec. The key is found everything within spec, especially on the resistance readings. What you might want to do next is do a run test in your test pit area to verify what your running amps are and compare them to the maximum required by the manufacturer to make sure those are within spec.